Alright kiddos, hope everyone's doing well. In this video I want to introduce to you some segment lengths formulas that pertain to circles and chords and secants and tangents. So here we go. There are several rules, kind of like angles, and the diagrams actually look very similar to those of the different types of angles relative to circles we've looked at. And so this I'm going to call the chord-chord rule, right? So this is our chord-chord, right? Because of course it's composed of two chords, right? So whenever we have this one and two chords, whenever we have this diagram, there are really four pieces, right? So we'll call that A, oops, and we'll call that piece B, and we'll call this piece C, and we'll call that piece, yep, D, you guessed it. So what happens is when two chords intersect at this point of intersection, the product of their pieces will be equivalent. Okay, not necessarily the whole chord lengths, but the product of their pieces will be equivalent, meaning A times B will be equal to D times C. Okay, so A times B, AB equals CD. Okay, so I call that the chord-chord rule. Most people do. It's the length. We're now talking length. So this length here would be A, that length here would be B, this length would be C, and this length would be D, right? So the product of the pieces of the two chords will be equivalent. Piece times piece equals piece times piece. Okay. Another rule relative to circles, and in this case secants, right? So what happens if we have lengths outside of the circle? So let's go here and here. And again, the diagrams look like the angle problems we've been doing, but now we're talking about lengths, right? And we'll do an example of each after I present each rule. And so for the secant, I'm going to call that secant, secant. Secant, secant, because of course it's created or comprised of one, two secants, right? And so when that does happen, I'm going to put a point right here and a point right here. And note that each particular secant has the whole length, right? The whole length, and then the outside piece. So I'm going to call that piece the outside of the first secant, outside of the second secant. Then of course there's the whole length of the whole secant, whole piece, and then this secant has a whole length as well, right? So what the secant rule says is the product of the whole times the out piece of the first one is equal to the product of the whole length times the outside length of the second. So the way I would write that is whole times out times whole, oops, the outside piece is equal to the second whole secant times its outside piece, right? So this length, whatever it is, of the whole secant times the outside length, which is from here to here, of the first secant is equal to the whole length times the outside length of the second secant. Okay, that's called the secant-secant rule. And then we have the final rule is the tangent-secant rule. Oops. And so this is a little bit different. We have a tangent, and I'll just kind of bonk what looks like a tangent there. And then we have a secant here. So I'll call that the tangent-secant rule. Right, and so of course here's our tangent here, and here's our secant. Now a tangent doesn't have a hole and an out. For a tangent, the outside is the hole, right? So I'll just call that the tangent. That's the distance here. And then the secant has a whole length, of course, but it also has an outside length. And by outside, I mean it's the length outside the circle here, right? So I kind of think of it as a secant-secant where the tangent is the out. So what we get here is the tangent squared is equal to the whole secant times the outside piece of that secant. Okay? So whatever this is squared is going to be equal to the whole secant length times the outside length of that same secant. Okay? So three basic rules for three different situations. Again, it looks very similar to, it looks the same as the diagrams with the angles and the arc measures, but in this case we're now talking about lengths of segments. Okay? So for example, let's kind of look at a couple of these, and let's do 1 and 2 for now. And we'll save the rest for tomorrow. Okay. So for number 1, I have a chord, right? I have a chord, so I'm going to use the chord rule. And what the chord rule says is that essentially the product of the pieces of each chord will be the same. Right? The chords don't have to be congruent. If they're both diameters, we know they will be congruent. But what we are going to know, however, is that 3 times x is going to equal 6 times 4. Right? So I'm going to use a chord rule to get 3 times x, piece times piece, equals product of the pieces of the other chord. Right? Or 3x equals, when I multiply 6 by 4, which means x is 8. Okay, so this length here would be 8 centimeters, or 8 inches, or 8 feet, or 8 units. Okay. Number 4 here, I'm looking at really 2 secants. So I'm going to use a secant rule. Secant, right? Now what's different about secants is that there's a whole length, and then there's an outside length, right? The length outside the circle. Right? So in this case, the whole length would be 12. Right? So I'll just note that that's 12. And then the outside piece would be 5. Shout out to Hoff.
5.
So, yeah. And then for this secant, the whole piece is going to be 6 plus x. So the whole is going to be 6 plus x. Right? It's the outside piece, which is 6, times the inside piece, which is x, plus rather. And the outside piece is going to be 6, right? So I'm going to use the secant rule, which says whole times out equals whole times out, essentially. Whole times out equals whole of the other one times out. And so I start on the bottom, so I'm going to get the whole, which is 12, times the out, which is 5, right? So 12 times 5. That's the 12 is the whole bottom secant times 5, which is the outside length, is going to be equal to the whole top secant, which is 6 plus x, times the outside piece, which is 6. 6 plus x times 6. Right? Notice I have the quantity 6 plus x, the whole 6 plus x, the quantity, times 6, the outside piece. Right? So now I'm just going to solve this. So I get 60 equals, and now I could do one of 2 things now. I could either distribute that 6, or I can divide by 6. I'm just going to divide by 6, right? So I get 10 equals, 10 equals 6 plus x, which of course makes x equal to 4. Okay? So that's that. Okay? Again, we're dealing with lengths of segments, and that is, if we use a chord rule here, we use a secant rule here. Okay? These are the 4 problems I want you to do now. Okay? Have those ready for tomorrow. You got chord, you got tangent secant, you got secant, and you got another secant. Oh, tangent secant. Okay? Good luck. We'll talk about these tomorrow. Bye-bye.